Today, I will explain what is parity, how we can calculate parity, and what are the uses of parity. In digital communication, transmitters send transmitted data plus 1 bit of parity to the receiver side. This 1 bit of parity determines either this data is correct or incorrect. There are two types of parity, even parity and odd parity. Usually in digital communication, even parity is used and calculated. Even parity, as the name implies, if the number of ones in the transmitted data are even, parity will be 0, else the parity will be 1. In odd parity, if the number of ones in the transmitted data are odd, then the parity will be calculated as 0, else the parity will be 1. Let's consider some examples. If transmitted data is 0011, even parity is calculated as 0 because there are even number of ones. If transmitted data is 110, even parity is calculated as 1 because there are odd number of ones. In case of transmitted data as 1010, even parity is calculated as 0 as there are two ones, which is even number. And in case of all zeros, the parity is 0 as 0 is also an even number. Now let's calculate odd parity. For transmitted data 0011, odd parity is 1 because there are even number of ones. For transmitted data 1110, odd parity is 0 as there are 3 number of ones and 3 is an odd number. For transmitted data 1010, odd parity is again 1 because of the even number of ones. At last, all zeros have 0 number of ones and 0 is an even number, so the odd parity is 1. The use of parity is error detection at the receiver side. Receiver side receives the transmitted data plus 1 bit of parity. Let's name this parity PR. Receiver also generates parity. Let's name this parity as calculated parity PC. Then the calculated parity is compared to the received parity. If the calculated parity is equal to the received parity, then the transmitted data is correct, else it's incorrect. Now let's find out either this received data is correct or incorrect. In this system, we are using even parity. If transmitted data is 0011 and 0 is the parity received, receiver calculates PC as 0. On comparison with PR, the transmitted data is found correct. If transmitted data is 1111 and PR is 1, PC is calculated as 0, which is not equal to 1, so the received data has some errors. If transmitted data is 1010 and PR is 1, PC is calculated as 0, which is different, so the received data has some problems. In the last, transmitted data is 0001 and 0 is the received parity. PC is calculated as 1. On comparison with received parity, this is incorrect, so the data received is also incorrect.